You ever wonder how your phone, your computer, or even your game console actually, thinks? How does it make all those little decisions every second? It can feel like magic, right? But it's actually a really simple and honestly kind of elegant system. So today, we're going to pull back that curtain and show you exactly how it all works.
No, seriously, think about it for a second. How does your smart thermostat know the room is getting chilly and it's time to kick on the heat? Or how does a video game register that final game-winning shot and declare you the champion? It's not some crazy, unknowable magic. It's something way more clever, and it is at the absolute heart of every piece of software you've ever used.
The secret ingredient here is a concept called control flow. You can think of it as the secret language of decision making. It's the blueprint that tells a program which path to take at any given moment, turning a bunch of simple instructions into what feels like, intelligent behavior. And the best part? It's way easier to understand than you might think.
Okay, let's dive right in with the most fundamental building block of all decision-making in code. This is ground zero. We're talking about the if statement.
So, at its core, an if statement is basically just asking a simple yes or no question. It tells the computer, hey, check this one thing for me. If, and only if, that thing is true, I want you to go ahead and do this specific action. And if the condition is false, the computer just kind of shrugs, skips that part completely, and moves right along to the next instruction. Simple as that.
To make this crystal clear, let's use an analogy we can all relate to, figuring out what to wear in the morning. It's just a series of little decisions, and the very first question you probably ask yourself when you look out the window is it raining?
And what you see here, this is exactly how a computer thinks. It checks one single condition, if weather equals raining. If the answer is yep, it's raining, then it triggers the action, take umbrella function. But if the weather is sunny or cloudy or anything else, that instruction to take the umbrella is just totally ignored. It's a one-way street, one question, one potential action.
Okay, but what if it's not raining? Right now, our little program just does nothing. It moves on. That's where we need a way to handle the alternative. We need a fork in the road.
And that is where the if-else statement comes into play. It creates that fork in the road we're talking about. It gives the computer two, and only two, clear paths. It says, if this condition is true, do action A. But for every other possibility, if it's false for any reason at all, then I want you to do action B instead. No more dead ends. Now every outcome has a plan. So back to our weather situation. This is like us saying, okay, if it's raining, I'm definitely taking my umbrella. But what's the alternative? Well, otherwise, I'll just leave it at home. See? We now have a clear plan for both outcomes, rainy and not rainy. And here's exactly how that looks in code. Our if check is still there, right at the top, but now we've added this else block. You should think of else as the default plan. It's the catch-all. If that initial check for rain fails, the program doesn't just stop. It automatically jumps down and runs the code inside the else block. This slide really shows that leap perfectly. On the left, with a simple if, you've got just one path. The program does something only if the condition is true, and does absolutely nothing otherwise. But on the right, with if-else, you have two paths. It's a true fork in the road, and you are guaranteed an outcome, which is a huge step up when you're trying to create smarter logic.
Right. But let's be real. Weather isn't just rainy or not rainy, is it? What if it's super sunny? Or what if it's snowing? Or windy? Our simple if-else structure can't really handle all those specific possibilities. We need a way to chain our questions together.
And to do that, we use the if-elif-else statement. That little elif is really just short for else if. It lets us build like a ladder of decisions. The computer starts at the top rung, it checks the if. If that's false, it just steps down to the first elif. If that one's false too, it just steps down to the next one. And it keeps going down the ladder until it finally finds a condition that's true. Now, the really crucial thing here is that it works like a checklist, and it goes in order. The computer asks, is it raining? Nope. Okay, then is it sunny? Nope. All right, how about snowing? Still no. And because it went through all of our specific checks and didn't get a yes, it finally lands on our default else action at the very bottom. Just wear your jacket. And here is the code that builds that exact ladder. Now, as soon as the program finds a condition that's true, it runs that one block of code, and then, and this is key, it jumps over all the other checks below it. So if it's sunny, it'll run the wear sunglasses code and then completely ignore the snowing check and the final else. It's super efficient that way. First match wins. So we've got if-elif, and else.
They might seem pretty basic, but let's connect this back to the real world, because these three simple tools are actually the foundation for pretty much every single decision made by the technology you interact with all day long.
That's it, really. Just these three little statements: if, elif, and else. You could call them the DNA of digital decision-making. And you might be shocked to learn that nearly every smart feature you use is built from thousands, sometimes millions, of these simple checks all nested together.
And I mean, just look at how this logic is literally everywhere. That enemy in your favorite video game, that's just a long series of if-elif checks. A login screen, that's a super simple, if your password is correct, else show an error message. Your social media feed, your GPS, your smart home devices, it is all just a massive, tangled web of these exact logical tests, firing off thousands of times every single second. So I'll just leave you with this thought. The next time you use a piece of software that seems impossibly smart, just remember what's really humming away under the hood. It's not magic, it's just simple logic, a vast, intricate cathedral built from millions and millions of simple questions, all starting with that one powerful little word, if.